Alright guys, welcome to Exquisite Tutorials. In today's video we are going to talk about partial fractions and we'll solve several questions to explain it deeply. Before we start, please do not forget to like to our YouTube channel, subscribe and share this video. Tell us how you think about it. Now let's start. Now what are partial fractions? Suppose you have 1 over x minus 1 plus 2 over x plus 1 and you are asked to simplify this expression. What would you do? First of all, you would say find the LCM, then you will get x minus 1, x plus 1. Then you will say this comes to this side, x plus 1 plus 2 brackets. This goes here. Now when you now open the bracket, you get x plus 1 plus 2x minus 2 all over x minus 1, x plus 1. X plus 2x, that's 3x. 1 minus 2, that's minus 1. So we've got this. Now you were able to take this to this form. You were able to take this to this form. Now how would you take this whole part back to this place? This is what partial fraction is all about. So the first question here is we are taking this back to this form. So we are going to have something over this expression here. When you have something like this, you are taking it back to this form. You are going to have something. It could be 1x, it could be 25x, it could be a constant number all over this. And you are still going to have something all over this. It is these two things that we are searching for. That is what partial fraction is all about. Now let's start with this question. So the first case is a case where there is no power here. There's no power here. All of them are linear factors. So the first thing is to let this to equal a over x plus 1 plus b over x minus 2 plus c over x minus 3. So we have done that. A over x plus 1, b over x minus 2, and c over x minus 3. So normally, how would you simplify this part of the expression? Simple. The way you simplify it is what we are going to do now. Now we do not know the value of a, b, and c. So these are the values we actually want to look for. So the first thing is to find the LCM here. So you have x plus 1, x minus 2, x minus 3. Now this whole thing here divided by this, you are left with only these two. So they will multiply a. You have a, x minus 2, x minus 3, plus b. This whole thing divided by this, you are left with just these two, x plus 1, x minus 3. So permit me to do this, plus c, x plus 1, x minus 2. So we have gotten the part, everything all over x plus 1, x minus 2, and x minus 3. So this is what we have simplified. Now these two things, we are saying they are equal, so they have the same denominator. So this denominator can go out. So we are left with 25 minus 11x equals a open bracket x minus 2, x minus 3, plus b open bracket x plus 1, x minus 3, plus c x plus 1, x minus 2. Now how do we look for a, b, and c? There are two ways. You can just compare the coefficients, which is long, or you can use the cover-up method. So in this video, because of time, we are going to use the cover-up method. Now, for me to get a, I have to eliminate b and c so that I will be looking for only a. Now, what will I put here as x in order to eliminate this? Or what will I put here as x in order to eliminate this? Or what will I put here as x in order to eliminate this? If x was 2, 2 minus 2 is 0. So I will be able to eliminate a. 2 minus 2 is 0. So I'll be able to eliminate a. So how do I know it's 2? X minus 2 equals 0. X is equals to 2. So when x is 2, 2 minus 2 becomes 0. So let's put x. Let x equals 2. So we have 25 minus 11 times 2. 2 minus 2 is 0. So everything here becomes 0. Then there's no 2 plus 1 is 3. 2 minus 1. 2 minus 3 is minus 1. Then we have 2 minus 2 here is 0. So this part is out of the game. So we are left with 25 minus 22 equals to minus 3b. 25 minus 22 is 3. 3 is equals to minus 3b. Now when I divide both sides by minus 3, I will get b as minus 1. So we have gotten that part. So we were able to eliminate b and c by imputing, we were able to eliminate a and c by imputing x as 2. Now how do we now eliminate another thing? We have imputed x as 2. Now what will make this part to be 0? What will make this part to be 0? If x plus 1 is 0, if x plus 1 is 0, it means that x is equals to minus 1. So if I put x as minus 1 here, this automatically turns to 0. So let x equals minus 1. So we have 25 minus 11 bracket minus 1 equals minus 1 minus 2 is minus 3. So we have a bracket minus 3. Minus 1 minus 3 is minus 4. Then minus 4. So we have gotten this part. Minus 1 plus 1 is 0. So there's no need to check anything. This part becomes 0. Minus 1 minus plus 1 is also 0. So this part is out. We are left with just this. So let's start. 25 minus times minus is plus. So we have 25 plus 11. Now minus times minus is also plus. 3 times 4 is 12. So we have 12a. 25 plus 11 is 36. So 12a, 12 divided by 12. When you divide everything by 12, a becomes 3. So we have gotten our value for a. Now we have used this to eliminate this. We have used this. There's one more factor that we have not used. We have not used x minus 3. We have used x as 2 to eliminate several things. We have used x minus as minus 1. Now let's use x minus 3. If x minus 3 is 0, x will be 3. So anytime I put 3 here, this becomes 0. If I put 3 here, this becomes 0. So let x be equal to 3. So we have 25 minus 11 times 3 equals, if x is 3, 3 minus 3 is 0, this part is 0. If x is 3, 3 minus 3 is 0, this part is 0. Let's impute x as 3 here. 3 plus 1, that's 4. So we have c bracket 4. Then 3 minus 2, that is 1. So we have 1. 25 minus 33, this is 25 minus 33 is equal to 4. Now what is 25 minus 33? That should be 8. This is 8c. That should be 8 minus 8 equals to 4c. Now when I divide both sides by 4, I'll get c as minus 2. So we have gotten our a, we have gotten our b, and we have gotten our c. Now I can now come back to this original question and impute a as 3 here. So anywhere I see a, I'll put 3. Anywhere I see b, I'll put minus 1. Now if I put minus 1 here, it's the same thing as removing this and put the minus here and leave the 1 here. So this is minus 1. Then our c is minus 2. So let me put the minus here and put the 2 here. So this has been simplified to this. Now if you decide to simplify this part, what you will get as your final answer will be this. So that's all for this first question. Let's move to the second case. Welcome back. This is the second case where there's a power. There's a power. Now the same procedure, you let this to be equal to a over x minus 2. But for this part that has power, you repeat it twice. The power is 2 here. So you repeat it twice, but in ascending powers. So you say b over x minus 1 raised to power 1 plus c over x minus 1 then square. So if this part was raised to power 3, you would have added d x raised to power minus 1 raised to power 3. But we are stopping at 2 because the power is 2 here. So you will keep increasing it like that. So that's it. As usual, you find the LCM. So x plus 1 over x minus 2, x minus 1 all square is equal to, now when you find the LCM, you get x minus 2, x minus 1 squared. Do not multiply this and say cube. No. The LCM of this and this is x minus 1 squared. So you just repeat the same thing here. Now when this is divided by this part, you get a open bracket x minus 1 all square plus b open bracket x minus 2 x minus 1 then plus c open bracket x minus 2. This is what you will get. Now as usual, they have the same denominator, you cancel out. So we are left with x plus 1 equals a bracket x minus 1 square plus b bracket x minus 2 x minus 1 plus c bracket x minus 2. You have to be very observant. We are looking for a, b and c. Now we have to eliminate two variables to find just one of the variable. Now how do we do that? There is x minus 2 here, or let's start with this. There's x minus 1 here. There's also x minus 1 here, but there is no x minus 1 here. So we can find a way to make this x minus 1 to be 0 so that these two parts will be eliminated. Now if x minus 1 is 0, what will be x? X will be 1. So anywhere I see this, I put x as 1. So let's put x as 1. This is 1 plus 1, it is 2. 1 minus 1 is 0. 0 squared is 0. 0 times a is 0. So this part is gone. 1 minus 1 is 0. 0 times any other thing is 0. So this part is gone. We are left with this part. 1 minus 2 is minus 1. So this is minus 2c. So when I divide both sides by minus 2. Sorry, this is minus 1. Minus c. 1 minus 2 is minus 1. So c becomes minus 2 when I divide both sides by minus 1. So we have gotten our c as minus 2. Now we have succeeded in eliminating a and b to get c. Now what do we do to get the others? Now I have made x minus 1 to be 0. Now there is x minus 2 here and there is also x minus 2 here. What if I make x minus 2 to be 0 since there is no x minus 2 here? Now if I make x minus 2 equals 0, I'll get x is equals to 2. So let me impute x as 2. 2 plus 1, that's 3, equals to 2 minus 1, that is 1. 1 squared is 1, equals to a. 2 minus 2, that's 0. So this part is gone. 2 minus 2, that's also 0. 0 times c, that part is gone. So we have gotten out a as 3. So what are the values of x we have tried? 1 and 2. But we use that to get a and c. Now it's left for us to get b. There's nothing to substitute again in order to eliminate a and c. So what you do, you can come up with any value. You can come up with any value of your choice. If you say let x equals 0, you can think of any value. You can say let x equals 1 over 2. You can say let x equals 3. You can say let x equals 5. Since you have gotten 2, you use them to find b. So I want to go with 0. Let x equals 0. 0 plus 1, that is 1, equals 0 minus 1 is minus 1. But when you square it, it becomes plus 1. So plus 1 times a, that is a. Then 0 minus 2 is minus 2. 0 minus 1 is minus 1. Minus 1 times minus 2 is plus 2. Then times it with b. You get plus 2b. Then for this last part, 0 minus 2 is minus 2. So we have minus 2c. Now how do we get our b? We already know that c is minus 2. And we already know that a is 3. So we can use that to get b. Now substitute it. What is our a? 3 plus 2b. What is our c? Minus 2. So this is minus 2 brackets minus 2 1, 3 plus 2b plus 4. 3 plus 4 is 7. So we have 1 is equals to 7 plus 2b. So when I take 7 to this side, 1 minus 7 becomes minus 6. So we have minus 6 is equals to 2b. Now I cannot divide both sides by 2. B becomes minus 3. So we have gotten our A, we have gotten our B, and we have gotten our C. I can easily substitute it. Anywhere I see A, I put 3 there. So this is 3 over x minus 2. Then our B is minus 3, so I can change it and put minus 3. Then our C is also minus 2. So I can write this as minus 2. So this is the answer for this. We have been able to make this and change it to this form if a power is repeated. If this power was not like this, we would have stopped here and solved. But because there's a power, that is why we continued like that. So that's all for case 2. Let's move over to case 3. Alright, this is the third case. Now sometimes they can give you your question in this form. Let's say you are given a question, expand this or write this as partial fraction. This is the same thing as x squared minus 1. So they can give you in this form and say write this as partial fraction. It is now left for you to factorize this part as x minus 1, x plus 1. It is left for you to factorize it to this form before you start solving. Now what if you are given in a form in which you cannot factorize? X squared plus x plus 1 cannot be factorized. If you try, you will get a complex value. If you try to factorize it, you will get a complex value. Now, anytime you find yourself in this case, this is what you do. Now, we have a linear factor here. We have a linear factor. So, as usual, we just write it a over that linear factor. But the problem is this factor that we can't factorize. What do? Check for the highest power of that factor. If the highest power of that factor is 2, what you write is bx plus c all over repeat the factor. Now, addition the highest power here was 3. Let's say you have x cubed plus 4x squared plus 3, or just suppose the highest power is 3 and it's unfactorizable. It must not be factorizable. If it is factorizable, you have to factorize it. Now, if it is not factorizable and the power of x, the highest power is 3, what you will put at this numerator will be x squared plus cx plus d. What did you observe? The power will drop by 1. The power dropped by 1. So if the highest power was 4, what you would have put at the numerator would have been bx raised to power 3, drop it by 1, then keep on dropping it like that. So this is for this case whereby a particular factor is not factorizable. Now let's start solving. As usual, you behave as if you want to simplify this part of the expression. So let's go. So this is a bracket x squared plus x plus 1 plus bx plus c bracket x minus 1, everything all over x minus 1, x squared plus x plus 1. Wow. So this part can cancel out. We are left with 2x plus 1 equals to a bracket x squared plus x plus 1 bracket or plus bx plus c x minus 1. As usual, now it is difficult to put something here to make this part 0. So let's focus on this part. If we can make this part to be 0, we can eliminate everything here and get our a. So now let's make this part 0. If x minus 1 is 0, what will be x? X will be 1. So I'll impute x as 1. So we have 2 times 1, which is 2. 2 plus 1 is 3. So we have 3 equals a. 1 square is 1. 1 is 1 plus another 1. So we have 1 plus 1 plus 1. That is 3. 3a. This part, 1 minus 1 is 0. So everything here becomes 0. So therefore, our a is 1. 3 divided by 3 is 1. So we have gotten our A. Now the problem is, how do we now get our B and our C? That is where the problem is now. Alright, what I'll do, I can see that there are two brackets here. Let me first of all open the bracket if something meaningful can come to my head. So let's do that. 2x plus 1 equals A bracket x squared plus x plus 1. Now bx we times this, c we times this. So plus bx times x minus 1 plus c bracket x minus 1. We have made x to be 1, so there's no use doing it again. Now if x was 0, we can eliminate b. If x was 0, we can eliminate b. So let's put x as 0. Now if x is 0, 2 times 0 is 0. So we have 1 equals to 0 plus 0 is 0 plus 1. So we have A plus 0 times b is 0. So this part has been eliminated. 0 minus 1 is minus 1. So we have minus c. So A minus c is equals 1. But remember that we have gotten our A. Our A is what? 1. So we'll put it here. 1 is equals 1 minus c. Now 1 minus 1 is 0. So our c automatically is 0. We have solved to get c. Mind you, c can be 2. You can solve and get c as 2. You can solve and get c as 3. It does not mean that all your c must be 0. Now we have gotten c. There's nothing to substitute again to eliminate anything. Now let's just form any value of x and put. Let us choose any value of x. We can choose 2. We have choose 0. We have used 1. Let's come up with any value. Let's try 2. Let's try 2. So 2 times 2 is 4. We have 4. 4 plus 1, that's 5. Equals 2 squared is 2. 2 plus 2, that is 4 plus 2. 2 squared is 4. 4 plus 2 is 6. Plus 1, that is 7. So we have 7a. Then for this part, we have 2 minus 1 is 1 times 2, that is 2. So we have plus 2b. Then for the last part, c, 2 minus 1 is 1. So we have plus c. But we have gotten our a to be 1 and we have gotten our c to be 0. So I will substitute it there. 7 times 1 is 7 plus 2b. Then c is 0. So no need to write that. So when I take 7 to this side, I will have 5 minus 7, which is minus 2. Minus 2 equals 2b. Now I cannot divide both sides by 2. So my b becomes minus 1. So with this, I have gotten the values of a, b, and c. I cannot impute those values here. Our a is 1, so I'll replace this and write 1. Our b is minus 1. So I can replace this and write minus 1x. No need for me to write the 1 since it's minus 1. Then our c is 0, so this can be written as 0. So, but there's no need of writing the 0 because adding 0 or subtracting 0 from anything makes no difference. So we have minus x here. Or I can decide to remove this plus and put the minus here. So that's all for this case. The last case will come up shortly. Stay with us. Alright, this is the last case for partial fraction. With this, we'll be done with partial fraction, the last case. Now, what can you observe about this case? Did you observe that the power of x here, the highest power of x here at the numerator is greater than that of the denominator? Now, this would lead us to what we call proper and improper fractions based on partial fractions. Because for you to call something a proper fraction, it means that it is lesser than 1. That all proper fractions are lesser than 1. That means the numerator is smaller than the denominator. Basically, the numerator here is dependent on the value of x you put here. If you put a value of x here that makes this numerator to be smaller than this becomes a proper fraction. But though in partial fraction, when we encounter something like this, we tend to call it an improper fraction. But in actual sense, for this to be an improper or a proper fraction or a whole number, it is dependent on the value of x. But for partial fraction, for P's to reign, anytime the highest power of x is at the numerator, take that as an improper fraction. Then if the highest power of x is at the denominator, take that as a proper fraction. So if you can be asked, which of the following is a proper fraction? X squared plus 3x plus 1, x plus 2 minus x cubed, x squared plus 4x all over x raised to the power 4 plus x plus 1, and x cubed plus x squared all over x raised to the power 5 plus x. Now the highest power of x here is 3, and it is at the denominator, so this is a proper fraction. The highest power of x here is at the denominator 2, so this is a proper fraction. Let me change this part to 5 and change this part to 3. The highest power of x here is at the numerator, so this is improper fraction. Improper fraction. So that's how you know improper fraction. But the question is, what's our business with this? That is the main question. What is our business with this? Now, when you do, sometimes you can have the same power of x, 3, the highest power of x, but you still follow the same procedure we want to do now. Now, what happens when you find an improper fraction? Let's say you have 7 over 2. Remember that 7 over 2, when you divide 7 by 2, you get 3 remainder 1. So this can be written as 3 whole number 1 over 2. If I don't want to write it this way, I can decide to write it as 3 plus this part 1 over 2. Now it is with this knowledge that we want to use to solve this. Because we know that the top is greater, we can now divide these polynomials so that we can end up having it as a mixed form. Then we write this in this form. I'm heading somewhere. Let's say you have 13 over 4. 13 divided by 4 is actually 3 remainder 1. Or let me say divided by 5. This is 2 remainder 3. So this can be written as 2 whole number 3 over 5. Or it can be written as 2 plus 3 over 5. So it is with this knowledge that we are to use to solve this. Now the first thing, because the power of x here is greater, if it was 2 also, you would have divided both of them 2. So let's work with that. Because the power of x here is greater, let's divide. So we have this x cubed plus x squared, long division. Then we have this part, x squared plus x minus 2. So the first thing, you are working with this term and this term. Arrange it in descending power of x. So x cubed divided by x squared, that is x. X times x cubed is x. X times x squared is x cubed. X times x is plus x squared. X times this is minus 2x. So we have this. Now we can now minus them. X cubed minus x cubed, that is 0. So no need to write it. X squared minus x squared is also 0. There's nothing that has x here. So let's do 0x minus 2x. That's plus 2x. Then we are left with a constant, 1 minus. There's no constant here, so we repeat the 1. So basically, we are done for this because 2x divided by x squared will be 1 over x. So let's stop here. We are going to stop here. Now, this is actually, when you divide this by this, you will get x whole number, the remainder over this. Just as you have 3 whole number, 1 over 2. Let's say you have 7 over 2, and you try to do that, you get 7 to remainder 1. So you say 3 whole number, 1 over 2. That is how you do x whole number, 1 over 2. Or you simply put 3 plus 1 over 2, or you simply put x plus 2x over this. So we have written this as mixed form, more like x whole number 2x plus 1 over x squared plus x minus 2. Mind you, I am not saying x times this. I'm saying x whole number this, which can be written as x plus 2x plus 1 all over x squared plus x minus 2. So I have been able to express this to this form. Now let me clean this part and rewrite it. So this, I've been able to write this as x plus 2x plus 1 all over x squared plus x minus 2. Now let me check if this is factorizable. If this is not factorizable, this will be my final answer. So I want to check if this is factorizable. Let's check. Think of two numbers that when you multiply, you get minus 2, and when you add, you get 1. Those two numbers are 2 and minus 1. 2 times minus 1 is minus 2. 2 minus 1 is plus 1. So this can be factorized to x plus 2x plus 1 all over x minus 1, then x plus 2. X plus 2. So this is it. Now, this part is simple already. It is this part that we will now convert to a partial fraction, because this part is like the first case we did. So it is this part that we will convert to partial fraction. So we say let this part, only this part, over x minus 1, x plus 2, equals a over x minus 1 plus b over x plus 2. As usual, you are going to have 2x plus 1, then a open bracket x plus 2 plus b open bracket x minus 1. Now what will I do to eliminate? If I make x minus 1 equals 0, this part, if I make x minus 1 equals 0, my x becomes 1. So let me impute x as 1. 2 times 1, 2 plus 1, that will be 3. Equals 1 plus 2 is 3. So we have 3a. 1 minus 1, that's 0. So this part is out. Therefore, our a is 1, because 3 divided by 3 is 1. So let's continue. Now, what do I do to eliminate? I've eliminated b to get a. Now, what do I do to eliminate this? Let this part equal 0. So if x plus 2 is 0, this times this will be 0. So if x plus 2 equals 0, our x becomes minus 2. So impute x as minus 2 here. 2 times minus 2 is minus 4. Minus 4 plus 1 is minus 3. So you have minus 3 equals to minus 2 plus 2 is 0. 0 times a, it has gone. So that part is out. Minus 2 minus 1, that's minus 3 times b. We have minus 3b. Now when you do this, divide both sides by minus 3. Our b becomes 1 also. How lucky. We are very lucky to get this. Now it means that this whole part is equal to 1. Our a is 1. And our b is 1 over this. So anywhere I see 2x plus 1 over this, I'll replace it and write this whole part. So it therefore means that this expressed in partial fraction is the same as x plus 1 over x minus 1. I repeated this x here. We are now substituting the value for this, which is this, plus 1 over x plus 2. So this is it. That's all for this video. We have been able to express this as partial fraction. Please do not forget, like and subscribe to our YouTube channel. Follow us on Facebook and various on WhatsApp. If you're on our WhatsApp group, you have no issues, you can DM us your questions and we'll start solving them for you. If you have any issues in mathematics, do not forget to state it in the comment section and we'll do a video for you. Comment, we need your comments, we need your likes. Thanks for watching.
Exclusive tutorials present 10 days RHEMA for DELSU 100 level students. Message to be part of this. You cannot miss this opportunity.